right? And let's go through our objective. So I can write, solve, and graph two variable inequalities. I can write, solve, and graph two variable inequalities. So again, one more time, we'll go over this. Less than, greater than, less than or greater than both have open circles for one variable inequalities. For two variable inequalities, we're going to be drawing lines. We're going to be drawing lines, which means we have to differentiate between less than and greater than, or less than or equal to and greater than or equal to. So for these, for the strict inequalities, we're going to use a dotted line. Don't worry, it'll make more sense in a minute. And then for the not strict inequalities, less than or equal to, greater than or equal to, instead of a closed circle, we're going to just use a solid line. Okay. So I want you to think about if we have something that's just y equals 6. It's just one variable. I would put that on a number line. I could represent it this way, 2, 4, 6. I would represent it just by putting a dot on a number line, right? Then when I had an inequality, if I wanted to put that on a number line, it becomes 0, 2, 4, 6, becomes a dot and becomes an array. It becomes that dot with a line, right? So representing many numbers. Okay. Then when we have a graph, let's say we have y equals x. So now we have an equation, not in one variable, but an equation in two variables. That becomes more than just a point. It becomes a whole series of points, right? It's going to become that whole line. And then now we're going to talk about inequalities, y less than x, in two variables. Instead of just one variable, there's two variables. So it's going to look like a line, but since this is just less than, it's going to be a dotted line. But then more than just the line, it's actually going to be a half plane. That's what we call it, half plane. So it's all of the values. When I say y is less than x, the solution is anywhere below this line. So it's not just one point or a line, like a series of points. It's going to be this entire half plane. Okay. So when we want to graph an inequality, I listed out a few steps. So the first thing we want to do is we want to replace the inequality symbol. So the less than, greater than, less than or equal to, greater than or equal to symbol with an equals sign. So we basically just change the inequality from an inequality into an equation. And we graph that line, and that's what we call our boundary line. Like I said, for less than or greater than, use a dashed line. So like this, dashed. For less than or equal to, greater than or equal to, use a solid line. And then in order to determine which side of the line to shade, I need to select a point not on the line and I test it. I'll go over how to do that. And then the solution is going to be the shaded half plane. Shaded half plane. Okay. Down here are some notes. So for inequalities written in standard form, what I want you to do is I want you to change it so that it's in slope-intercept form. And then once we have an inequality in slope-intercept form, we have to find two things. What two things can we grab from the slope-intercept form? No. Slope and the y-intercept. We graph the y-intercept and then use the slope to draw the line. That's where we'll pick up tomorrow. So I want you to hand in the packet that we were just working on, and then the inequalities practice page. You should hold on to your inequalities in one variable notes packet. That's for you. Okay? Cool. Thank you. Have